Hi, everyone. Nice to meet you. So my name is Vishakh. I'm a PhD student at CDS, where I'm part of the Machine Learning for Language group, and I work with her on natural language processing and human-AI collaboration. So what we've been thinking about quite recently is kind of what happens when you put language models in the presence of real users and, yeah, examine different effects there. So for the rest of this talk, if I use the word LLM, it refers to like large language models. I'm sure everybody's familiar with this given recent events, but yeah. In this particular project, what I'm going to be talking about is, does writing with language models reduce content diversity? And I'll come back to why this might be important at the end of the talk, but we're going to talk about some fairly low-level details first, which is, so our work is kind of inspired by two different directions of research, where some results from social science have actually found that, like, in the presence of these language models, people's political views can actually be affected and impacted. And additionally, what's happening now is many different users are each using the same model. The canonical example is ChatGPT, where everybody around the world uses the same tool to write emails. And this has the potential to create what's called an algorithmic monoculture, and there's a long line of research here. But specific to our topic, what we're going to ask is, when we collaborate with large language models to write, do we end up writing more similarly to each other, and does this reduce the overall content diversity? So how can we study this tool? So typically, like in my work, we study this by means of user studies, which basically means that the format looks something like this, and I'll walk you through the different steps. So what's happening here is, we want to elicit people's opinions writing with language models. So we collect argumentative essays on open-ended topics, such as this, such as like, it's very easy for anyone to write about what students should learn at school, and it's also fairly reasonably expected that people have very differing views about this. What we do then is we collect essays on the basis of this prompt from three different setups. So the blue line on top is solo writers. It's just people writing without any model help. And then we also collect people writing with two different models. So GPT-3 and Instruct-GPT are kind of OpenAI's, let's say, state-of-the-art API releases that are publicly available to a lot of people to use. So the reason why we differentiate these two kinds of models is, on a fairly broad level, Instruct-GPT is kind of viewed as the better model according to a lot of traditional benchmarks and performance-based metrics, with the reason being that Instruct-GPT is basically, you take GPT-3 and then adapt it on the basis of human feedback. So on a high level, again, what we're basically doing is we're collecting essays that humans write both with and without model help, and we differentiate between the kinds of models, and I'll come to why we do that on a later slide. So what we're going to talk from now is, we're going to compare the actual essays that people write with and without model help. And we can maybe come to examples at the end, but yeah. So the first research question is, fundamentally, are people writing more similarly? And I'm going to talk about results, but I'm hopefully going to walk you through this. So our contribution in this paper is, first we formalize what's called a homogenization score. So what you see on the y-axis of this plot is basically homogenization, or the average similarity of a particular essay to what all the other essays that come from the same setup, which basically means that a person writes about what I think kids should be taught at school, how similar is it to all the other essays that are written in the different setups. So in this case, a higher y-axis value basically corresponds to more similar writing. And yeah, I feel like one thing that's important here is, how do you measure this similarity? In this particular figure, we use this metric called Rouge-L. These are all standard metrics, but I want to say that our results are general across many different of these kind of metrics, and these results are kind of in the paper. So first, when you just look at across all of the topics that we collect, across all of the topics, we do find that writing with Instruct-GPT results in more homogenization or more similar essays, which basically means that the green box plot on the right is more similar when users write with Instruct-GPT as compared to the other two setups. And because these are a pointwise measure that we've designed, like, you can actually take the homogenization scores and do statistical testing, and you can actually see that with statistical significance, people do write more similarly with Instruct-GPT. And when you dig down further into the details, so we collected essays from many different topics. So one of them was the school that I spoke to you earlier about. We actually have 10 different kinds of topics. And we observed that this effect is fairly general. Across 7 of the 10 topics, the median homogenization of writing with Instruct GPT is actually higher than the highest as compared to the other setups. The effect of the homogenization is different slightly based on the topic, and we actually select this wide range of topics to kind of account for that. So for example, if you look at the end, there's stereotypes. In general, people write less similarly about stereotypes because people have very diverse opinions. Whereas like, yeah, some other things like animal welfare and college athletes, people write more similarly on average across all setups. So yeah, the general takeaway being that writing with Instruct GPT generally seems to increase this homogenization. But one kind of weird result, which surprised us as well, but maybe in hindsight it makes sense, which is that the other language model that I spoke about, GPT-3, which was the initial language model without human feedback training, actually doesn't have that much of an impact. And that kind of surprised us, which basically kind of tells you that the performance gains that you get when you went from GPT-3 to Instruct GPT kind of come at this cost of homogeneity. And I feel like this is something which didn't exist before. And now maybe when you deploy these language models in user-facing situations, we think that this is a sign that you should, it's a different axis on which to evaluate these products. Because do you want people writing more similarly? In some cases, it doesn't matter. Like in emails, who really cares? But like if actually you want to be writing stories or original papers or something, you might care about these metrics. So yeah, our work kind of highlights the difference between the kinds of language models and the impact of the intervention. So this is sort of result 1. The second research question is overall diversity, which is a little bit harder to kind of measure because what does it even mean to measure diversity? And like very broadly, diversity typically refers to the fraction of unique information in like a particular set of essays. And this is not super well defined. So we make one claim, which is that you can compare the content of the essays using summarization. So what do I mean is, let's say this is an example essay, right? Like this is something about like screen time, and people have written about like, I don't know, I think this person wrote about teenagers, it not being an issue with just teenagers. And what we can do is, we can take this essay, which is at the raw text level, and we can summarize it into atomic key points, which basically means that I can feed the individual essay in, and I can extract atomic key points of the content of that particular essay. And what I can now do is, if I frame this individual key point as a unit of content, I can use this to formalize diversity. And specifically, the key points that you see on the bottom, what we contend is that you can measure diversity as the fraction of unique key points across all of the essays. And this is through any traditional like clustering technique, which are like super well studied. So an example to maybe make this clear is, let's say you have 2 different essays and you have a bunch of key points that come from them. The particular specifics, I mean, I'll leave you to read that if you want. But the idea is that when you do clustering, what you do is you find similar key points. So you might look at these 2 key points across 2 different essays, and you find that they're reasonably similar, so you can maybe cluster them together. And in this process, you can find many separate clusters of key points and measure the diversity as the fraction. So basically, out of the 6 key points on your screen, maybe you actually only have 4 unique key points. So this gives you a principal measure of this diversity. And what happens? Like, what do we actually find with this diversity measure? Again, boring results table. But so one caveat here is when you do clustering, there's actually a hyperparameter in the algorithm which says how similar should an element be for it to be clustered. And we actually vary that a lot. And we also have results for different measures of clustering. But it seems quite clear that across all of the thresholds and even across all of the similarity measures that we look at, again, writing with Instruct GPT reduces this content diversity than the other 2 setups. And I feel like this is one thing which is a little bit more important than earlier measures. So previous works that look at like diversity, they talk about like word levels, words, phrases. And I'm sure we've seen this, right? Like ChatGPT tells us these similar phrases. But the impact of reduced content diversity is perhaps a little more like broad, and there are even like some social considerations, and like English teachers have come back to us with some of the concerns of like these kinds of findings. And I think, yeah, it's fairly like broad that you can go from here. But yeah, I'll leave you with just some takeaways, and hopefully we do have time for questions, which is the 2 takeaways from our work is it does seem that collaborating with Instruct GPT results in people writing more similar essays with reduced diversity as a whole. And we do observe that this effect is not as much with the traditional GPT-3. And this kind of maybe tells you that the feedback tuning that we're doing, and actually like there's a whole science on like how to best use the human feedback. It kind of tells you that this performance bump using human feedback comes at a cost. And yeah, I guess that's my time. And yeah, please reach out to me if there's any time for questions. Cool. So typically, so when you say prompt engineering, what you basically change is what is provided to the language model in order to elicit different results, right? And in our case, as the people are writing, they're writing fundamentally different essays as it is, right? So in a way, our users do the prompt engineering by like providing slightly different context on the basis of that. We did experiment with like if you explicitly say, don't write similar things, or like, the traditional simple tricks of prompt engineering don't solve this issue. And actually, like, when you look at the output distribution of Instruct GPT, it's actually more narrow itself. So it's definitely like something principled arising from the additional feedback tuning. I don't want to make the claim that there exists no prompt engineering solution, but I think the concern is how scalable is that? Like, how much prompt engineering are you going to do? And like, you don't know for your different use cases what's the best prompt. And like, I feel like this is something, especially the user doesn't want to bother with. So you, as the provider, might have to do it. I don't know the economics of this, but I guess that's sense.
My question would be about kind of identify the different topics. Does that mean that?
Yeah.
The kind of the same.
Yeah.
Yeah. Do you have any hypotheses for like why these why these dynamics? Is it because they're or is there going to be thought about how we dive into that?
So yeah, one actually way that you can think a little bit about this is what are the different views on the internet about these particular topics. And there are like works that like scrape, so there are open source like pre-training data sets, and people scrape these data sets for how frequently, like, let's say college athletes are measured online. And let's say there's like a wide consensus on what people think about college athletes online. That's going to be reflected more on the language model, and like that has the potential. But making the causal claim is quite hard. You could do like a correlation analysis of like frequency of these topics in pre-training. That's the way you would go forward with that. I think there was one more in the back. Yeah. That's actually a very, very important question. And actually, like, the self-feeding loops is another issue, right? Because let's say, like, I share exactly your concern, where I use ChatGPT to write emails, and it just suggests, like, I mean, for want of a better word, like Western internet information, right? And so now you kind of, like, marginalized groups are writing more similar to the, let's say, the mode of the content. So you actually lose diversity of information on the internet. So it's a very big concern, and people have been, but it's very hard to measure this because, like, the measure that we presented for diversity, it's not actually that scalable. In this case, for 100 essays, it's still very expensive. I can't even imagine doing this for the internet. So, but the feedback loop is a big concern, and actually there is some, like, very recent work talking about this, and yeah, I don't have a solution. I think this is a problem, and yeah, we'll see where we go. Yeah. We're good? Okay, cool. Sure. Sounds good. Yeah. Reach out to me. Yeah, I'll probably be downstairs. Yeah, of course. Also, yeah, email me. My name is, my first name at nyu.edu. Sure. We'll see something. Yeah. Yeah.